Hello friends and my dear students, I welcome you all to my channel. I hope you're all well and your studies are also going on well. This is part 3 video on the chapter of parallelograms where I will discuss about some necessary conditions of a quadrilateral to be a parallelogram along with proof. Also, I will address something incorrect that I said in the previous video, that is part 2, regarding parallel lines and another line intersecting two parallel lines. I will address that in this video. I will not solve any problems in this video, but this I have prepared a set of problems on the quadrilaterals and properties of quadrilaterals and parallelograms. This is assignment number 1. The link of the assignment PDF will be there in the description below. And please note that whenever you watch my videos, always look at the description to get useful information regarding my videos. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 3 video on the chapter of parallelograms. Okay, so I have prepared the list of conditions, necessary conditions for a quadrilateral to be a parallelogram. But before that, let me quickly address that in the previous video part 2, I was talking about, I was solving some problems, and you know that when we have two parallel lines, let's say these two are parallel lines L and M, and there is another line, let's say P, that intersects these two parallel lines L and M at distinct points, let's say Q and R, then this the line L and M need not be parallel. There can be any two straight lines, and if another straight line P intersects the straight lines L and M at distinct points Q and R, then the line P is known as transversal. I was referring this line as a transcendental, so that's the mistake I did. So this is known as transversal. And transversal is a concept, is a straight line that intersects two other straight lines, two or more other straight lines at two distinct points. There could be more straight lines. Let's say this is straight lines, let's say R, and the line P is intersecting at the point S. So we can say that P is a transversal to the lines L and M, and also you can say P is also a transversal to the lines M and R. So this line, the straight line P that intersects two or more other straight lines at distinct points is known as transversal, not transcendental. So this is something I want to address before I start today's video. Okay, let me delete this part. Okay, so there are there are four conditions. There are four conditions that makes a quadrilateral to become a parallel. Now, it is not the fact that all these four conditions need to be true at the same time. No, any of these conditions, if any of these conditions is true, then in a quadrilateral, then we can say that quadrilateral is a parallelogram. There are four such conditions. Condition 1 is that each pair of opposite sides are equal. So if in a quadrilateral both the pair of opposite sides are equal, it will be a parallelogram. Condition 2 is that if each pair of opposite angles are equal, then also the quadrilateral will be a parallelogram. And the third one is that if in a quadrilateral the diagonals bisect each other, then also that quadrilateral will be a parallelogram. And the last one is that if one pair of opposite sides in a quadrilateral are equal and parallel, then also that quadrilateral will be a parallelogram. I will try to give proof of this of these conditions that will make a quadrilateral a parallelogram. Okay, so first one is each pair of opposite sides are equal. So please, even though the diagram is looking like a parallelogram, please don't be biased that this is a parallelogram. Consider that ABCD is a quadrilateral. Okay, so we have ABCD is a quadrilateral, and we know that each pair of opposite sides are equal. So we know that its opposite sides AB and DC are equal, and AD and BC are equal. So this proof is pretty simple and straightforward. You just make the diagonal, connect the opposite vertices A and C to make the diagonal AC. Now clearly we can see that if you consider the triangle ADC and triangle ABC, so all these proofs are heavily based on congruence of triangles. Okay, so in triangle ADC and ABC, clearly we have AB, clearly we have AD is equal to BC based on the fact that the opposite sides are equal. AD is equal to BC, and we have DC is equal to AB, and AC is the AC equal to AC common side. This is the common side. So this implies we have SSS congruence, SSS congruence satisfied. Okay, now you need to be very careful in establishing the correspondence between the vertices and angles and sides of the two triangles. So this will imply that triangle ADC will be congruent to triangle. Now you have to name the congruence relation carefully. Now we know that AD is equal to BC. Okay, AD is equal to BC. Okay, DC is equal to AB. DC is equal to AD is equal to BC, and it is now in establishing the congruence relation, that is the correspondence between the angles, vertices and sides. It is more, I think, easy and straightforward if you can somehow manage to find the correspondence relation between the vertices. Now so what you do is, so you take two sides that are equal to two other sides of the other triangle. You take two sides of the triangle ADC. I am considering AD and DC, two sides. Okay. In triangle AD and in triangle so we know that AD is equal to BC, okay, and DC is equal to AB. Now, what is the angle included between the side AD and DC? That is the angle D. Okay. Now, what is the angle included between the side BC and AB? BC and AB, that is B. So, definitely angle D will be congruent to angle B. You can, from this you can also say that the vertex D has the corresponding vertex of D will be B. Okay. Now you take any other two side of the triangle ADC. So AD is equal to BC we know, and then let's say AC is equal to AC. So what is the angle included between the side AD and AC? AD and AC, that is the angle A. And what is the angle included between the side BC and AC? PC and BC and AC, that is the angle C. So we have angle A is congruent or having a correspondence to angle C. So this will imply A, the vertex A is corresponding vertex is C. So once you have established correspondence between two vertices of two triangles in a congruence relationship, the other vertex is obvious. So we have I'm not sure whether what the correspondence, what is the symbol for correspondence? I forgot. Maybe I forgot. Okay, so I'm using the symbol right hand arrow. So clearly we are having A is having a correspondence to that is the vertex A. Its correspondence vertex, the vertex A of triangle ADC is mapped to or is having a correspondence with the vertex C of triangle ABC. Similarly, D, vertex D of triangle ADC is having a correspondence with the vertex B of the triangle ABC. So clearly the remaining vertex in triangle ADC is C. So definitely C will have a correspondence with the vertex A of the triangle ABC. So this is the mapping of the vertices of the two triangles ADC and ABC which are congruent. So if we now want to write the congruence relationship, so triangle ADC will be congruent to triangle C, B and A, C, B, A. Now, okay, so clearly we see now to prove that the quadrilateral ABCD is a parallelogram, what we need that we need to prove that AB is parallel to DC and AD is parallel to BC. We need to prove that AB is parallel to DC and AD is parallel to BC. Now, okay, so we can see that angle DAC is equal to angle ACB. Okay, and AC is a transversal. AC is a transversal to AD and BC. So you must be knowing from the properties of parallel lines and transversal that if we have a transversal and two straight lines, that is a transversal cutting two straight lines, then we have alternate interior angles. If the alternate interior angles are equal, then the two straight lines that is being cut by the transversal are parallel. So in this case, let's say we have from the congruence relation, we are having angle DAC is equal to angle ACB, and AC is a transversal to AD and BC, and also the angle DAC and these are alternate, as you can see, interior angles. Angle DAC and angle ACB are alternate interior angles. So clearly this will now as a result we can say that AD is parallel to BC. So one pair of opposite sides is proved to be parallel. Similarly, we have to mm, prove that AB is parallel to DC. AB is parallel to DC. Okay. For that, okay. Now, from the congruence, since the triangle ADC and triangle CBA are congruent, from this fact, we also can say that angle CAB. So angle A is congruent to is having a correspondence to angle C. Okay, so we can say that angle CAD of triangle ADC is equal to angle ACB. No, sorry, not this one. From the congruence of the two triangles, we have to okay. So since C, the vertex C is having a vertex C of triangle ADC is having a correspondence to vertex A of triangle ABC, we can say that angle ACD is equal to angle CAB, from the fact that angle the vertex C is having a correspondence with the vertex A of the vertex C of triangle ADC is having a correspondence with the vertex A of the triangle ABC, we can say that this angle is the angle produced at the vertex C of triangle ADC, and this angle is the angle produced at the vertex A of the triangle ABC. So, and since vertex C is mapped to vertex A, we can say these two angles are equal. Now you can see that also we can see that AC is a transversal to AB and DC. AC is clearly a transversal to AB and DC, and we are having angle ACD is equal to angle CAB, which are alternate interior angles. So we can say that AB has to be parallel to DC. So this is the other pair of opposite sides are proved to be parallel, and this is another pair of opposite sides proved to be parallel. So these two together, these two will definitely we can say that ABCD is a parallelogram. So this is a shorthand notation for a parallelogram. So two parallel lines and GM, this means parallelogram. So ABCD is a parallelogram. Since we have proved both of its opposite sides are parallel. That is the definition of a parallelogram. Okay. Let's see the condition 2. It says that if each pair of opposite angles are equal, then also the quadrilateral, in any quadrilateral, if the opposite angles are equal, then also it will be a parallelogram. Okay. So in this quadrilateral, what is given? It is given that angle A is equal to angle C, as they are opposite angles, and we have angle B is equal to angle D. These are given. That is, opposite pair of opposite angles are equal. These are given. Okay. How can we now prove that ABCD is a parallelogram? That is, we need to prove that AB is parallel to DC and AD is parallel to BC. Hmm. These two angles are equal. Okay. These two angles are equal. Hmm. Angle A is equal to angle C and angle D. Okay. Uh, if I make the diagonal BD, can we can we prove that triangle ABD is congruent to triangle BDC? We have these two angles equal. Oh no. Hmm. Each pair of opposite angles are equal. Each pair of opposite angles are equal. Think we have to uh, use both the diagonals. Mm, this is equal to this. Each pair of opposite angles are equal. Mm. This is equal to this. Each pair of opposite angles are equal. Mm, this is this one side. We are having one side equal and one angle equal. Mm, this is the common side. If you consider the triangle ADC and ABC, AC is the common side, and angle D is given to be equal to angle B. This is equal to this. This makes right. Mm, let me delete the diagonal AC. If we consider the triangle ADB and BDC, this angle is equal to this, and this angle is equal to this angle. this mm, this is equal to this. Uh, I'm stuck how to prove that this will be a parallelogram based on the fact that opposite pair of angles are equal. I will skip for the time being. I will come to the proof of this condition later on. Let me finish the other two. So condition 3 is diagonals bisect each other. It is given that the diagonals bisect each other. So let's first draw the diagonals. So ABCD is a quadrilateral and the diagonals BD they bisect each other. Let's say they bisect at the point O. So given what is given, we only have the fact that AO is equal to OC and DO is equal to OB. AO is equal to OC and DO is equal to OB. Okay, so we have this is equal to this and this is equal to this. We need to consider the triangles AOD, and in triangle AOD and triangle BOC, if we consider these two angles, these two triangles, we have the vertically opposite angles are equal, that is angle AOD is vertically opposite to angle BOC, so they will be equal, and we have AO equal to OC and we have DO is equal to OB. Clearly, we can see that one angle, the vertically opposite angles is included between the two other sides. So from this equality of one angle and two sides, we can say the congruence criteria satisfied is side angle side, that is an angle between two sides, and the angle here is angle AOD of triangle ADO AOD and angle BOC of triangle BOC. So this is we have SAS congruence satisfied. So let's name the what will be the congruence relationship. Triangle AOD, triangle, now triangle AOD will be congruent to let's quickly establish the correspondence of the vertices. Okay, so we have clearly O is the common vertex, so definitely O will be mapped to O, and so side, and angle. AO is equal to OC. AO is equal to OC and DO is equal to OB. Now, from the fact that AO is equal to OC and so AD will be equal to BC, AD will be equal to BC, and A, C, DB. I think it will be congruent to triangle triangle COB. COB. So AO is equal to CO, okay. OD is equal to OB and AD is equal to BC. Okay, so this is fine. So if we have this congruence relationship established between the triangles AOD and triangle OBC, so from this congruence relation we can say that angle A, that angle DAC, DAO of triangle AOD will be equal to angle DAO means BCO. So we have this angle is equal to this angle, and we have DAO is equal to BCO, and we see that AC is transversal. AC is transversal to AD and BC, and the angles angle DAO and angle BCO are alternate interior angles. So from here we can easily say that AD is parallel to BC. AD is parallel to BC. Okay. What else can we say? AD is parallel to BC. Also, from the congruence relation, also we get that PD is parallel to BC. Now, I think to prove that AB is parallel to DC, we need to consider two other triangles for congruence, that is triangle AOB and DOC. From the congruence relation of a triangle AOD and BOC, we cannot prove that AB is parallel to DC because the sides AB and BC are AB and DC are not involved. So we have to consider again in triangle AOB and triangle DOC, we have obviously the pair of opposite angles is equal, that is angle AOB is equal to vertically opposite angles DOC. Also we have AO is equal to OC, and we have DO is equal to OB. So definitely again we have SAS congruence satisfied. That is the vertically opposite angle and its two sides, that is the vertically opposite angle is the angle included between two sides. The corresponding sides, the two sides of triangle AOB is AO and OB, and the corresponding sides of triangle DOC is OC and OD. So we must have triangle AOB should be congruent to triangle AOB, I think CO AOB is congruent to COD. So let me check. AO is equal to CO, okay. OB is equal to OD, and DC is equal to AB, okay. From this congruence relation, we can say that uh, the corresponding angles will also be equal. So we will have angle ADO should be equal to angle the corresponding vertex of A is C. So C, O is O, and D is D ADO. So ABO. This will be, sorry, this is ABO. ABO, this angle should be equal to angle ABO should be equal to angle the corresponding C, D, and CDO. So this angle. So these two angles are equal. Now we can see that these two angles are interior, alternate interior angles to the. So we see and we know that BD is a transversal to BD is a transversal to AB and DC. AB and DC, and angle ABO and angle CDO are alternate interior angles and they are equal. So this implies AB must be parallel to DC. So we have proved the opposite sides, the pair of opposite sides AB and DC, they are parallel. Also we have proved that the other pair of opposite sides AD and BC are parallel. Hence, these two fact sorry for my weird explanation. These two fact will imply that ABCD is a parallelogram. The two pair of opposite sides are parallel. Hence, ABCD, the quadrilateral ABCD, will be a parallelogram. Okay. The condition 4 is that if one pair of opposite sides are equal and parallel, then also the quadrilateral will be a parallelogram. So without any loss of generality, let's say it is given, we are considering that AD, let's say AB is equal to DC and also they are parallel. Given that AB is equal to DC and AB parallel to DC. From these two facts, we have to prove that this quadrilateral ABCD is a parallelogram. Okay, so I think this will be easy. We make the diagonal BD and we consider the so we have, okay, so since first AB is parallel to DC, it is given, and BD is a transversal. Therefore, the alternating angles, alternate interior angles will be equal. This implies angle ABD should be equal to angle BDC. That is, this angle should be equal to this angle based on the given fact that AB is parallel to DC. Now, in triangle, we consider the triangle ABD and triangle BDC to establish a congruence relation. So we know that in this two triangle, we already have angle ABD. Angle ABD is equal to angle BDC. BD is equal to BD, the common side. Also, we have another side that is given to be equal, that is AB is equal to DC. So clearly we can see we have side, angle, side, congruence satisfied. The alternate interior angles is the angle between two sides of the two triangles that are equal. So SAS congruence satisfied. Hence, the congruence relationship will be triangle ABD should be congruent to the vertex B definitely should be should have a correspondence to vertex D. So we must have B is corresponding to D. So we have B D. What is the corresponding vertex of A? AB is corresponding to DC. AB is corresponding to DC, and angle ABC, angle ABD is equal to angle BDC. So congruence, SAS congruence is satisfied. Now, what will be the congruence relation based on the SAS? Now, from a congruence relation, whenever we establish congruence criteria is satisfied, that is, if it is SSS or SAS or ASA or RHS, from that we should be clearly able to name the relationship, that is congruence relationship, and from the congruence relationship it will be obvious the corresponding vertices. Now BD is equal to BD, AB is equal to B, AB is equal to DC, AB is equal to DC, and BD is equal to BD. Now this implies, this also implies that angle ABD, we can say BDC. Angle ABD is equal to angle BDC means that angle B of triangle ABD is equal to BDC, angle D of triangle BDC. Okay. So B is having a correspondence with D. B is having a correspondence with D. That is fine. B is having a correspondence with D. Okay. So B is having a correspondence with D, and we know that AB is equal to DC. So these two facts, that AB is equal to DC and B is having a correspondence with D, this implies that A should have a correspondence with C. So definitely this will be C and this will be B. I think this is correct. The triangle ABD is having a is congruent with triangle CDB. Let me check. AB is equal to CD, BD is equal to BD, and DA is equal to PC. Okay, fine. Now, okay, so from here we can see we have to find other corresponding equal angles to establish that fact that that AD is parallel to BC. It is already given AB is parallel to DC. We just need to prove that AD is parallel to BC. Okay. Now, from this we can say that angle from triangle ABD, angle ADB should be, from the congruence relation, we can easily say it should be that angle ADB should be equal to angle CB and CBD. So we have this angle equal, and we also have, and BD is a transversal to AD and BC, and also angle ADB and angle CBD are alternate interior angles to the where BD is a transversal to AD and BC. So this implies that AD is parallel to BC. So we have proved that the other two opposite sides are also parallel, and hence it was already given that AB is parallel to DC, and we have proved that AD is parallel to BC. So these two will prove that ABCD is a parallelogram. Okay. Now, the other condition which I failed to prove, this is each pair of opposite angles are equal. Each pair of opposite angles are equal. If in a quadrilateral each pair of opposite angles are equal, then it will be a parallelogram. So we are given angle A is equal to angle C and angle B is equal to angle D. How do we prove that ABCD is a parallelogram? Angle A is equal to angle C. Opposite angles are equal. I think, let's see. So we know that in a quadrilateral, we know that the sum of the interior angles, I always refer the sum of interior angles as SOI. In short, sum of interior angles will be 180 degree multiplied as per the formula, multiplied by n minus 2, n is 4, so 4 minus 2. Or we know that it is, you should be knowing that from the properties of quadrilateral, that the sum of the interior angles of a quadrilateral is always 360 degree. So this is 2, this is equal to 360 degree. Okay. Now this means that angle A plus angle B plus angle C plus angle D is equal to 360 degree. Now this implies that angle A plus angle B, since angle A is equal to angle C, instead of I am substituting angle C with angle A, will angle A, and since angle B is equal to angle D, I am substituting angle D as angle B. So we have this. So the left hand side, after simplification, you can see it will be twice of angle A plus angle B is equal to 360 degree. So this implies angle A plus angle B is equal to 360 degree by 2, which is equal to 180 degree. So we see and also and angle A, angle B are adjacent angles. Adjacent angles. Angle A and angle B are adjacent angles. Also, that AB is a transversal. AB is a transversal to AD and BC. So you see the two straight lines, the sides AD and BC is being cut by the line or the side AB. So AB is a transversal to AD and BC, and also the angle A and angle B are the co-interior angles. Angle A, angle B are co-interior angles to the transversal AB, because they are on the same side of the transversal, are co-interior angles. So if and their sum is 180 degree. So there is a condition that if in a transversal cutting two, if AB is a transversal cutting the straight lines AD and BC, such that its two co-interior angles, their sum is equal to 180 degree, then the two straight lines AD and BC has to be parallel. This is a concept from transversal and co-interior angles. Since we know that if we know that if a transversal is cutting two parallel lines, then the sum of two co-interior angles is equal to 180 degree. The reverse is also true. If we know that the sum of the two co-interior angles is 180 degree, then we can say that the transversal is cutting two parallel lines. So we can say that AD should be parallel to BC. So we have proved that one pair of opposite sides are parallel. We now need to prove that AB is parallel to DC. AD is parallel to DC. The proof will be the similar. So instead of at this step, instead of substituting C with A, to prove that AB is parallel to BC, AB is parallel to DC, we need to prove that angle B plus angle C is equal to, angle B and angle C are adjacent, are co-interior angles. Will be co-interior angles where BC will be a transversal to AB and DC. But first we need to prove that angle B and angle C is equal to 180 degree. Okay, so from the first we can say that angle A I will replace with angle C. So angle C plus angle B plus angle C plus angle D, I will substitute angle D with B, because angle D is equal to angle B is equal to 360 degrees. So similarly as before, we will have angle B plus angle C is equal to 180 degree, 360 degree. So this will imply angle B plus angle C is equal to 180 degree. So you can see that angle B and angle C, their sum is 180 degree, and angle B and angle C are co-interior angles to the transversal BC, cutting the two lines which are sides AB and DC. And BC is transversal to AB and DC. this will imply that AB is parallel to DC. So these two facts, you will say that ABCD is a parallelogram because we have proved that both the opposite pair of sides are parallel. So this brings to an end of proving the four necessary conditions, all four conditions that will make a quadrilateral to be a parallelogram. If any of these conditions is satisfied in a quadrilateral, then we can say that the quadrilateral is a parallelogram. I hope this video was beneficial. If it is so, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. Also, please try to solve the problems of assignment 1 that whose link will be there in the description below. I will provide the solution to problems of assignment 1 very soon in the next 24 hours. I will end the video here. Thanks for watching, and until the next video, take care and bye.